Great day, everyone. Once again, welcome back to our course on inferential statistics. And I am your instructor, Sir Ivan Brian L. Indagpibo. So, previously we discussed about the preliminaries and basic concepts, as well as sampling techniques, and the recent discussion that we had on descriptive statistics. Now we really embark on our course, inferential statistics. Going back to the definition of terms, inferential statistics deals with the analysis and relationship, correlation, and comparison, and even regression of data gathered, collected, and consolidated due and by virtue of our descriptive statistics. So, inferential statistics embarks on what descriptive statistics or data had already provided. And as the word implies, it generates something new. It generates a conclusion or what we could call as inference. So to infer means to arrive at something new or to generate a new information out of the given. Um, a sort of synthesis. So inferential statistics as part of statistics is already the higher statistics or the advanced statistics. And in most of the books that you will encounter, inferential statistics will be divided into usually two uh, measures, or at times you will encounter even three measures. So, what are these measures or tests? Inferential statistics are usually aggregated in terms of the different statistical tests or treatment. There are what you call tests of differences. The intention here is to compare data, whether one is significantly different from the other. So whether there's a significant increase or decrease, or a significant difference in comparison to pairs or groups, or more than three groups of data, then you are dealing with what we call test of differences. When you hear questions or a statement of the problem that starts with, is there significant difference or are there significant differences? Let's say, I'll give you an example. Are there significant differences in the level of maturity among students when grouped according to sections? Or another will be, are there significant differences in the teaching competence of selected teachers when grouped according to their educational attainment? So this kind of questions, if you will see the similarities, will directly inquire on the comparison or differences of data, or let's say the variable that you are given from the grouping variable. So when you say the data coming from the statistics, let's say the variable that you're talking about, awareness, intelligence quotient, or different variables that are labeled as independent or dependent. And then you will be grouping them according to the groups of um, population or respondents or participants that you have, then you'll see whether this grouping could indicate an increase or a significant decrease, or simply in either way significant difference in every group. So you again is are dealing with what we call the test of difference. Simply when you're comparing sets of data or groups of data from one group to another group, whether they're pre-test or post-test, whether they're the control group or the experimental group, or whether all the sections in a grade level, comparing their performances, comparing their attributes or their traits, or other elements or factors or variables, again, you're dealing with test of difference. Is that clear? The second will be the test of relationship. Um, Test of relationship, as the word imply, looks at whether one element or one factor or trait is related or affiliated to another trait or factor or variable. So you might test one independent and another dependent, or two dependent variables in that case. The matter here will be how much one influences the other. But there's a caveat here. The test of relationship, rather, is not really looking at the cause effect relationship. It does not imply that one is the cause of the other. The effect is caused by another element or factor or variable. Instead, it merely tells you how much one factor influences strongly or weakly, positively or negatively, a certain component, trait, variable, or element or factor. And that is the test of relationship. Set for example, you wanted to see whether the educational attainment affects the level of commitment a teacher or a personnel has. So you might ask the question, is there a significant relationship between the educational attainment and level of commitment among your participants? See that? Or maybe you might want to see how much influence are there if a student studies longer, or let's say devote time in his studying and the performance in his written works or performance tasks. You might see whether, or maybe you can posit this question, is there significant relationship to the number of hours or study hours a student has and the level of learning outcome? So again, I am not implying cause effect here, but what I'm saying is that whether one may strongly or weakly, positively or negatively influence another variable. So uh, the degree of influence here, or the degree of relationship, is tested here. And that's the reason why we call it test of relationship. So again, the questions that you might encounter from these tests usually are sounding in this manner. Is there relationship, or is there significant relationship, or is there significant correlation between one from the other or to the other? So that's the test of relationship. In other books, the test of relationship is further divided into what we call test of correlation and test of regression. Regression will embark already on a higher plane of statistics, and usually this is um, ventured under advanced statistics in the PhD or education doctor degrees. But in this case, when you say test of regression, from the word itself, regress, you're looking at how much impact or how much degree this variable contributes to the outcome. So this is more parametric or more reliable and more specific to the amount of influence or to the amount of degree it contributes to the outcome. Again, I am not implying cause and effect, but it is closely uh, embodies or foreshadows the experimental cause effect at times. But the point here is when you say regression, there are already multiple variables that you might employ. There are multinomial regression analysis. There are factor analysis. But regression is different from relationship. Relationship here, or at times they call it correlation, looks at how one, again, influences or related to the other. It might not be the cause, the source on how the effect happens, but one way or another, you see the pattern on how this one is influenced, or might be looking at the pattern on how this perform and how the other also performs. If there is a increasing pattern and the other variable also has the same increasing pattern, then most likely the stronger their correlation is. are. So that's the reason why we try to look at the test of relationship. The test of relationship tries to give us knowledge or information whether certain factors might be the cause or may influence other factors. So we will focus on this course on the two tests, test of differences and test of relationship. Again, when your question sounds like this, are there significant differences? You are talking about test of differences. But when your question sounds like this, is there significant correlation or is there significant relationship between one variable and the other? Then that speaks of the test of relationship. Now, like descriptive statistics, there are different tests or measures. In the inferential side, we are only dealing with two. However, it's not as simple as respective to the two that you only have two statistical treatments as well. You need to understand that when you're dealing with the test, you are also need to understand that you are also analyzing the type of data that you hold. That's the reason why previously we discussed the scales of measurement or the levels of measurement. Why? The level or the scale or simply the type of data that you hold speaks of and influence later on the kind of analysis or statistical treatment that you will be utilizing. So you start here. The question on whether what kind of or level of measurement do you hold, do you have, or have you gathered from your survey, from your questionnaire. So in the level of measurement, you need to understand that these types of data or levels of measurement correspondingly are analyzed and later on, subsequently, factored in the selection of what type of test you're going to use. So if you have interval and ratio, these are both numerical data, most likely you will be employing a better type of tests as compared to ordinal, which is usually gradated or there are levels of information or data given, and as also opposed to the nominal types of data or what you call categorical. When you say categorical, these are usually letters to words to labels to names. They are non-numerical. So labeling this as numerical, ordinal, or categorical, or even nominal at times, it will allow you to, again, analyze it further. What kind of test I'm going to use? If you have numerical data, it is most likely that you will be using parametric tests. Now, there are two types of tests here according to its reliability and according to how much it will yield reliable results or the power of the test. If you have numbers on hand, it is easier to compute and to, of course, employ mathematics. As simple as that. When you have numerical data, it is a candidate for us to use parametric tests. What are parametric tests? Parametric tests are ideal tests. Remember back in our key definitions and concepts, parameter speaks of the population. Okay? Statistics speaks of later on the level of the participant or on the samples. So when you say parameter, it is already the foreshadowing or embodying the standard, the totality, the entirety. So when you say it's a parametric test, most likely what you will garner here, what you will um, take here or get from here will be a more powerful, a more reliable result. Okay? So that's the reason why this is most likely, again, the preference of most statisticians to use parametric tests. However, because this is the ideal test, this is the more reliable test, you need to understand that you need to satisfy the assumptions before using the parametric test. And one of which is that your data should be interval ratio or what we call numerical. Now, in the event that your data is not numerical, let's say you have levels, gradations, or what we call as ordinal data, and then you have nominal data, immediately and automatically your test will be non-parametric or what we call the alternative tests. That's why you call alternative, because this is the test that you will use as alternative to the parametric test or simply the non-parametric test. Non-parametric in a sense that it's more difficult to process and analyze labels, words, letters, and also layers or levels or degrees, as opposed to purely numerical data. But still, we need to process it, we need to analyze it. And that's the reason why we have a repertoire of non-parametric tests. In the event that, again, going back to the parametric tests, in the event that you have not satisfied the assumptions laid down on the tests that requires it, even though your scale of measurement or level of measurement is numerical, even the data that you hold is interval ratio, but nonetheless you have failed to meet the criteria or assumption or the conditions needed to be met in the use of parametric test, your data will end up used being used in the non-parametric test, or you need to opt to use non-parametric options. So again, the first assumption here or criteria or condition in the use of parametric is that your data should be numbers, numerical, interval ratio. For example, scores, age, or temperature. Okay. So if not, again, if your data is ordinal and categorical, immediately you will be using non-parametric. But if it's numerical, you need to ask whether you have satisfied the other conditions or assumption. What's the other assumption aside from numerical? I'll give you at least three. Okay. In the parametric test, there are also other two assumptions here. As I have discussed in descriptive statistics, the ideal curve here should be a normally distributed data or the normally distributed curve. Remember that, the bell curve? If your data is normally distributed, then you are I you need to opt or you can use parametric test. If your data is not normally distributed, what's an example of this? If your data is skewed, say skewed to the left or skewed to the right, then you need to resort to non-parametric tests. How so? Why? Because when you say your data is skewed, let's say you interviewed participants that are not randomized, but the purpose of your study is to reflect the entire population. You only selected, let's say, in a society, you wanted to see, let's say, the social and economic makeup of the entire society, and yet you only interviewed the middle to the high class society or high class people or citizen or the filthy rich citizens only, then that's skewed. Or inversely speaking, majority of your respondents or participants are on the marginalized or um, class D and E of the society. Then again, your distribution is skewed. Will it result and represent the picture of the society? Will it yield a reliable result? From the beginning, it is already presumptive that it is not because it is not normally distributed. For example, you wanted to see whether this school is a very good school for your students, for your learners. And yet, when you try to survey, you only interviewed top performing students. Will the result be reflective of the status of the school? Will it represent the quality of education in the school? Yes, partly, which means it's only skewed. And that's the reason why we need a data that is normally distributed. And that's also the reason why we randomize the selection of data. Remember in our sampling technique. The third condition here in the usage of parametric tests is that your number of samples should also be bigger. Higher number of samples entails more reliable results. If you have the entire Philippines as your target population and you wanted to survey who will be the next most likely candidate for presidency that the people wanted, or let's say the pulse of the nation, you need to have a higher number of samples. Will it be sufficient to only gather 100 Filipinos and come up to a conclusion that the result out of the survey of 100 Filipinos is already reflective of the opinion and the pulse of the entire nation? That is, again, the dilemma if you have a lesser number of samples. In a simple research or basic, let's say, action research, what is the minimum number of samples? For parametric tests, and this is mostly indicated in some books, but not all, they will already accept around 30 participants at a minimum. But for strict statisticians, they will suggest even up to 50 participants or 50 packs for your for the minimum number of samples. So you could yield some sense in the results. The generalizability of a result lies also not just on the parametric test that you use, but also to the number of participants you have involved or the number of samples you have included in your study. So just imagine here, you're teaching in a school and you have, let's say, 6 sections, and each of the section consists of 40 students. And then suddenly one day in one of your section, there are 2 students who went to the school principal and complained against you. The complaint was that our teacher is not teaching, but you have not heard any complaint against this teacher from the other sections. The principal have not heard any other students who went and complained that the teacher is not teaching. The question here is the complaint an actionable complaint, and is the complaint reflective to the entire teaching competence that you have? And lastly, is the complaint reliable? Of course, the school principal will look into this matter. Okay? Sensibly speaking, you need to, of course, probe what really happened. But will you already jump into conclusion that this is a very reliable and a compelling concern and a problem that is prevalent? I believe you may say no. What if the same scenario you're still teaching 6 sections and each section consists of 40 students, and in each section there are 5 to 10 students, 5 in every section, let's say, who went to the principal's office and complained against you, telling our dear principal, our teacher is not really teaching. So will this yield a reliable result? I hope the two factors here, the two conditions or assumption here, will also enlighten you that the use of parametric tests is really conditioned whether your data is normally distributed, whether your data are numerical, and whether your data has a high volume of sample. That's the 3N: numerical, number of samples are high, and normally distributed. Again, for you to use parametric tests. In the event one of this is not satisfied, you end up resorting to non-parametric tests because Even though you try to insist on using the parametric test, it will not garner and ensure that the result is reliable. Okay? So the parametric test is ideal for, again, normally distributed, high number of samples, and basically numerical data or interval ratio data. For ordinal and nominal, immediately you will resort to non-parametric tests. So what are these tests? Okay, let's survey the different tests, the different inferential tests that are parametric and non-parametric. Both applied, again, whether your data is numerical, ordinal, or nominal. So let's start with tests of differences.